Good morning, dear students. I welcome you to the third class in physics. Today we are going to do the first exercise of numerical problems for the chapter Measurements and Experimentation. Before we start with the numerical problems, let's have a quick recap of what we studied in our previous two classes. Children, we studied about physical quantity. Then I told you that unit is very important to express a physical quantity. And then we discussed about the two types of units, that is fundamental and derived units. We also did three fundamental units, that is length, mass and time. And in detail we discussed about the multiple units and the subunits of these three fundamental units. Thereafter I gave you the three magical ladders for length, mass and time for your convenience. I hope you must have gone through the previous lecture carefully. Now before I start with the before solving the numerical problems, I would rather focus on a topic called order of magnitude, because this is going to be applied to solve the numerical problems. Now in physics, whenever you have to express a given physical quantity, for example here I have taken a physical quantity, that is the distance traveled by a car, to be 2800 meters. I need to change it into the right order of magnitude. Now what is that? In case of order of magnitude, you should have only one particular digit towards the left hand side, as you can see here. But initially there are 4 digits. So what am I going to do? I'm going to introduce a decimal. And then this decimal I'm going to shift in such a manner that I should have only one digit towards the left. Now here there are 3 jumps. The decimal is taking 3 jumps, 1, 2 and 3, and therefore the value is 2.8. Now whenever the decimal jumps towards the left side, the power will be a positive power. So it will be 2.8 into 10 to the power 3, because the decimal is jumping 3 places. So it will be 10 to the power 3 meters. Now if I take the second example, it is the mass of an object taken to be 0.0000625 kg. Here you can see that again I need one digit to the left. 0 is not a digit. So this decimal needs to jump, and let's see how many jumps will it take. It takes 1, 2, 3, 4 and 5. So the value becomes 6.25, and because it is taking 5 jumps towards the right, it will be raised to negative value. So the final value will be 6.25 into 10 to the power minus 5 kg. Now this order of magnitude I am going to apply to solve the numerical problems. Now for convenience, what have I done? I have already readied the data for you. Here in the first numerical problem, it is given that, see here I am reading it out, the wavelength of light of a particular color is 5800 angstroms. So remember children, wavelength is denoted by lambda. It is 5800 angstrom, and we need to express it in nanometer and meter. That's the question. Now how do we go about it? We first write down 1 angstrom is equal to, let's see the relation, 10 to the power minus 1 nanometer. Okay, now we need to change 5800 angstroms. So 5800 angstroms will be equal to 5800 into 10 to the power minus 1. Okay, so now what is 10 to the power minus 1? 10 to the power minus 1 is 1 by 10. The 0 cancels with the 0, and my ultimate final answer is 580 nanometer. Now see the second part. I need to convert angstrom to meters. What's the relation? 1 angstrom is 10 to the power minus 10 meters. So therefore 5800 angstroms will be equal to 5800 into 10 to the power minus 10. Okay, so now I will convert 5800 into, what is 10 to the power minus 10? 1 by 10 to the power 10. The 10 zeros will cancel with 2, so 8 remain behind. So what do I get? 58 into 1 upon 10 to the power 8. Now when I bring this 10 to the power 8 up, it becomes 58 into 10 to the power minus 8. Now you can see that it needs to be changed into the right order of magnitude. For that I will introduce a decimal, and the decimal will shift 1 towards the left. So it will be 5.8 into 10 to the power minus 8, because the decimal has shifted 1 place towards the left, plus 1. So the final answer will be 5.8 into 10 to the power minus 7 meters. This is the first numerical problem. Now let's move on to the second numerical problem. In the second numerical problem, it has been given that the size of bacteria is equal to 1 micron. And you are supposed to find out the number of bacteria present in 1 meter. Let's work out the relation. 1 meter is equal to 10 to the power 6 microns. Okay, children? So therefore, the number of bacteria in 1 meter, is equal to how much? Because the size of one bacteria is 1 micron, so the number of bacteria in 1 meter will be equal to 10 to the power 6. That's your answer. Look at the third numerical problem. It says the distance of a galaxy is equal to 5.6 into 10 to the power 25 meters. This is given to you. The speed of light is also given to you. You need to find out the time taken. Okay, now we are going to use the formula speed is equal to distance upon time. Let's put the values. Speed is 3 into 10 to the power 8 meters per second, and the distance is 5.6 into 10 to the power 25 meters, and we are supposed to find out the time. Okay, now how will we find out the time? Time will be equal to 5.6 into 10 to the power 25 upon 3 into 10 to the power 8. Okay, now for convenience I'll remove the decimal. So that will be 56 upon 30 into 10 to the power. What about the powers? 25, and this 8 when it goes up minus 8. We follow the rule of indices over here. The powers when divided are subtracted. So therefore we get T is equal to, what is 56 divided by 30? 1.87. Okay, and what is 25 minus 8? It is equal to 17. So the unit of time is second. So therefore my answer is 1.87 into 10 to the power 17 seconds. Okay, so this is the third numerical. Now for convenience and in order to save time, I have solved the remaining 4th, 5th, 6th and 7th numerical. I'll quickly do these numericals with you. The fourth question says that the wavelength of light is given to be 589 nanometers. You need to convert it into angstrom. Now how to go about it, children? 1 nanometer is equal to 10 angstroms. Now you need to convert 589 nanometer to angstrom. That will be 589 into 10. So that becomes 5890 angstroms. That's your answer. Look at the next question. It has been given to you in this question that the mass of an oxygen atom is equal to 16 U. What does the U stand for? AMU, atomic mass unit. So you need to find out the mass in kg. Let's work out. One atomic mass unit we know is equal to 1.66 into 10 to the power minus 27 kg. This we already know. So 16 atomic mass unit will be equal to 16 multiplied by 1.66 into 10 to the power minus 27 kg. When I multiply, my answer comes to 26.56 into 10 to the power minus 27. Now, you can see that this is not in the right order of magnitude. I need to shift the decimal 1 towards the left side. Now, when I shift it, my answer becomes 2.656 into 10 to the power minus 27. Because the decimal has shifted 1 place towards the left, it is plus 1. So, my final answer is 2.656 into 10 to the power minus 26 kg. Fine, children. Now let's move on to the sixth numerical problem. In the sixth numerical problem, it has been given to you that the time taken by light to reach from the sun to the earth is 8 minutes. 8 minutes. Okay. The speed of light is given to be 3 into 10 to the power 8 meters per second. You can see this is meter per second and this is minute. This has to be in the same unit, So the minute needs to be changed to second. That's why I multiply it by 60. 1 minute is 60 seconds. So I get 480 seconds. Now I need to find out the distance of the light. Okay. And that too in kilometers. I take the formula speed is equal to distance upon time. I substitute the value of speed. I substitute the value of time. I need to find out the distance. I cross multiply. And finally, my answer is 1440 into 10 to the power 8 meters. But the answer asked is in kilometers. So, children, that in order to convert meter to kilometer, I divide by 1000. Now, when I divide this value by 1000, the 0 cancels and my answer is 1.44 into 10 to the power 8 kilometers. You can see that it is already in the proper order of magnitude. So I need not do any change. This is my final answer. Now I come to the last question of the exercise, that is the 7th numerical, in which it is given that the distance of the star from the earth is 8.33 light minutes. This is given to you and they have told you to express the distance in meters. Now if you remember children, I have already taught you that 1 light minute is 3 into 10 to power 8 meters per second into 60 seconds. So when I multiply this, I get it as 180 into 10 to power 8. Now I need to find out the distance traveled in 8.33 light minutes. So that will be 8.33 into 3 into 10 to power 8 into 60. When I finally calculate it, my answer comes to 1499.4, which is approximately equal to 1500 into 10 to power 8 meters. Now you can see it is not in the proper order of magnitude. So I need to put a decimal here. First I'll put a decimal and I'm going to shift it by 1, 2 and 3 places. So towards my left. So it becomes 1.5 into 10 to power 8 plus 3. So my final answer is 1.5 into 10 to power 11 meters. So here children, I wind up with all the 7 numericals of the exercise. Please go through the numericals carefully and I want you to solve all these numericals again in your fair physics files. I will also send you the proper pictures of these solved numerical problems on Snap Homework. You can refer to these numericals and try to solve them on your own and be confident about them. Thank you children and have a nice day.